Okay, in this video we're going to take a look at a constant speed example. So let's take the scenario of a long distance runner who is running at a constant rate of 4.2 miles per hour for a time of 12 minutes. We want to know how far has he run, or how fast is she running after 27 minutes. We want to know both that. I guess I said he, she. I should say he, she to be consistent. All right, the first question, when we read a word problem like this, I think this is the first one we'll be doing basically this year. We got to identify what we are given. So if I look at this, I'm given a time of 12 minutes, I'm giving a rate, which is a velocity, and I know it's constant. So I'm going to say my V average is 4.2 miles per hour. This is my givens. And it's constant, so it doesn't change. So we can use the same V throughout the problem. And the time interval over which the distance runner is running is 12 minutes. Okay, and we want to know, our unknown here is how far has he or she run. So I want to know a distance or a displacement. So really, I could use velocity here. I could also say this is speed. I could use speed and distance. You can use velocity and displacement. It's all in one direction, so really it doesn't matter. Either or would be the same thing. This is what we want to solve for. And then we'll do the second part later. Well, first thing I got to do here to solve this problem, it might look easy on the outset because I know, well, if I have velocity average and that stays the same and I have delta t, I know that average velocity is displacement over time interval. And if I have any two, I can solve for the other. But it's a little more tricky than that because we have to make sure that we're using units that are consistent. Now, in certain problems, we're going to want to go into standard units, our SI units, metric units of meters and seconds. In this case, let's just stick with miles and hours, so for how far we can stick with miles. But before I solve this problem, I have hours here in my speed and I have minutes here. So I'm going to have to make a conversion in order to make sure I'm comparing apples with apples. So let's convert the minutes to hours, and then I'll have miles per hour and hours. So when I do this and solve for delta x, I will get hours. No, miles. I'm sorry. Hours will cancel out. So let's do this conversion first. So if I have 12 minutes and I want to convert to hours, we do a multiple by 1. So I have 1 hour for every 60 minutes. My minutes cancel. I'm left with hours. So I have 12 over 60 hours, which is 0.2 hours. So that's my time in hours. All right, so now I have miles per hour and hours. Let's solve for delta x. So I have average velocity is delta x over t, delta t. If this is constant, this stays the same. So I'm going to eliminate the t on this side by multiplying both sides by delta t. Then I have delta x by itself. So my displacement is my velocity times my time interval, which is 4.2 miles per hour times 0.2 hours. Hours cancel, so I get delta x is 4.2 times 0.2. I should do that in my head. Just to make sure I don't make a mistake, I will do it on the calculator. 0.84 miles. So in 12 minutes at 4.2 miles per hour, I go 0.84 miles. Now, how fast is he or she running after 27 minutes? Okay, well, if we have another new time interval of 27 minutes, and we want to know my new average velocity, I need to use some other information in this problem. I am told here that I'm moving at a constant rate of 4.2 miles per hour. Constant rate means rate doesn't change. Velocity stays the same. So after 27 minutes, the velocity will still be 4.2 miles per hour. So remember, keep your units consistent. Make sure you're not canceling out the wrong units. When you write it out in your problem, you should see that you end up with units that are of the variable you're solving for, in this case miles for a distance. The hours cancel, so you double check that and make sure you're doing it all properly.